All right, so we are good to go. All right, good. Yeah, so we said conservation, we essentially keep it the same, right? We keep something the same, in my opinion here. So we went back to the analogy of the water in a pipe, and we said that if there's a hole here, right, and it's letting no water, right, we block that hole to conserve the water. So the same amount of water before passing over the blockage is the same amount of water after. So we essentially conserve it. Same thing with momentum, right? So in the conservation of momentum, right, when two or more objects collide, their total momentum remains.
Well, I swear.
All right, so this is Renika. I'm going to have to mute you. All right. Yeah, so we were saying that when two objects collide, their total momentum remains the same. And we did this in class with the two bodies, right? We had mass one here and another mass here. I think it was a larger mass. And we saw that as when both of the objects collided, the total momentum for the entire system was the same before the collision and it was the same after the collision, right? So the total momentum remains constant provided that no force is acting on them or no additional force is lost. All right. So the total momentum before is equal to the total momentum after collision. Right. Now we can move on to the formula. So the last time we had a mass one here, we added the momentum for mass one, and I don't remember exactly how much it was, right? And then we had the momentum for mass two, right? And we added them, and we saw where both of them were the same. So mass one, this is the momentum for mass one, the momentum, right, for mass one, and momentum for mass two. So this is equal to the momentum after. Now, what is this up here? This is the thing. It's a apostrophe, right? It is used to tell that it is after. So anytime you see this, it's after collision. Anytime you see that with the apostrophe there, it means that it is after the collision happened. All right. So let's go through it. So the momentum of mass one, right? This is momentum of mass one, and this is the momentum for mass two, right? Before collision. Before the collision. Then the momentum for mass one after the collision and the momentum for mass two after the collision. All right,
Sure.
so question?
What is the V1?
Yeah, V1 would be the velocity of mass one. V2 would be the velocity for mass two, right? And then V1 prime, right? Prime is the velocity for mass one after the collision. And m2 prime, right, is the velocity for mass 2 after the collision, right? So are we clear? Everyone understand?
Yes, sir.
All right.
Yes, sir.
Okay. All right. Anyone not clear? Please speak now.
Sir, you lose me long time.
All right. Where did I lose it?
Long time.
Where exactly?
Right. From your start,
Am I started?
yeah.
All right. Let's
I
go
just
back.
try sketch on to what me can sketch on because I don't really want a nine nobody else.
All right. So this is Miss Van Horn, right?
Yes, sir.
Uh, we're at the last class.
Yeah,
So why didn't you indicate that you're not understanding? Did you read over the notes?
I'm trying to, but Lord,
And did you try watching over the videos?
no watch, me not watch the video yet.
Yeah. So the best thing I can say now, because we don't have much time left, right? We're going to we're going to see what we can try and go over for now. But I recommend that if this is the case again, if you're not understanding, try watching over the videos. All right, try watching over the videos even after this class, and you can do further research. Right, you have YouTube, but the essential thing that we want to accomplish from Miss Van Horn today is that momentum. The sign for momentum is P. It looks like a P, right? It's P. The sign for momentum, P equal mv, right? So momentum equal the mass of the object times the velocity. All right, so Ms. Van Horn, please get your calculator for me. I am trying my best to help you, right? You have a calculator on you?
I'm going.
Okay, let's work through this.
I have it now.
All right, so what is the momentum for this Lamborghini here? Do you have it?
Sir, I get 52,000.
Come again? What answer do you have?
I got 52, 52. What? 52,000.
No. Remember, we're looking at the momentum. So it is mass times velocity. So what is the mass of this object?
1,000 kg.
Yeah. So 1000 kg times what?
25.
Times 25. Right? So what is your final answer?
25,000.
Right, 25,000. And the unit, right? We have kg and we have meters per second. So we just put them together, right?
Yes, sir.
Yeah. So we have kg meters per second. Very easy. This is our momentum for our Lamborghini. For our Corolla, what is our momentum?
Oh, for that I got 52,000.
You got how much?
52,000.
52,000.
That's what I got.
All right, let me double check it. All right, so 52,500, right?
Yes, sir.
And what's our unit again?
Uh, kg meters per second. So
All right, so everyone else understands this particular part?
Yes, sir.
Yeah, so if we understand this, right, if we understand this, then the rest should be easy, right? The rest should be easy. We not let us not look at impulse for now. All right, let's not look at impulse. Let's try and get the conservation. So we did the same thing. We found the mass of we found the momentum for our Lambo, and then we found the momentum for our Corolla. Right? It's the same thing. It's basically the same thing, right? And if both of those collided, what is the total momentum for the system? Let us add 25,000 to 52,500.
77,500.
Yeah, so 77,500 is our total momentum. So this would be the total momentum for the entire system if those two were coming together. So this equal sign shows that those two collided. So their individual momentum would change, but the total momentum for the system would still be 77,500. That is what we're trying to get here. That is what we want to try and master. So the system is 77,500, but if they collide, they may have a slight difference. But what we want to accomplish, this equal sign shows that they just collided. It just shows that they collided, right? But after they collided, it is still 77,500. It does not change. Are we clear? That's what we want to try and accomplish for this
Yes,
slide.
sir.
All right, so Ms. Virgo is good. And
Bye.
Yes, sir.
okay, and Ms. Van Horn is good.
Yes.
All right, that's good, that's good. So we just want to accomplish that if we there's a collision between these two objects, if there's a collision between these two objects, right? The momentum before the collision, right? Is momentum before the collision will be the momentum after the collision. The individual momentums might change and the velocity of the objects might change, but the total momentum for the system will not change. Okay, now we can look at the two types of collision. Two types of collision. So we have inelastic collision and we have elastic collision. Somebody want to guess what inelastic collision mean? Inelastic collision. What do you think that means?
When both objects stick together after the
All
collision.
right, that sounds good. So when both objects stick together after the collision, so they stay together, they will have the same velocity. Very important. They will have the same velocity. They will not have different velocity like v1 prime and v2 prime. They will just have one velocity v, a big velocity v, right? Both objects will be the same. Now, look on what I think elastic collision is. If elastic
When they
collision,
separate after collision.
right? So the objects they separate themselves after they collide. After they collide, they move away from each other, right? Are we clear on that? Are we clear?
Yes, sir.
All right.
Sir, man, no wait. One is me. I go strong and
Miss Johnson, I believe it just came in, right?
no.
Sir, I'll just watch over the class. I'll eventually understand because
That's weird, cause me not understand one thing where the talk say.
All right. Miss Johnson, what exactly are you not understanding?
Everything you know where they do.
We just went over it a while ago with Miss Van Horn.
The bomba me just tell us me know.
Please watch your language, all right? I don't want to have to remove anyone out of this class. All right? Let us calm down for a second. I'll do it over one last time, right? For the persons who just came in and for Miss Johnson. All right? Okay. Miss Johnson, please pay attention now. I'm going to ask you to do this over. All right, let's do this over again. All right, Miss Johnson, please pay attention. Please find the momentum for this particular object here. What is the momentum for this object? I'm going to need a participation, right? Doing it over. Miss Johnson, please. What is the momentum for this object here? How will you calculate that?
Who the answer, sir? Me?
Yeah.
Momentum equal mass time velocity.
Right. So what's the momentum for this object here?
25,000 ms -1. Yeah.
25,000. So we multiply 25 times 1,000. So what you saying not understanding now?
Because okay, sir, me get what you say.
You're not getting this particular slide?
Yes, sir, me get this now. Me I get if you understand.
And you understand this too?
Sir, me I try to understand this now, sir.
All right. So if these two objects collided, what we're trying to say is that this particular momentum, we multiplied mass times velocity for this corolla here, and we got 52,500, right? Kilograms meters second. That's what we got. And the total momentum is 77,500, right? That's the total momentum. Now, this would be the 77,500 before the collision of these two objects. That's what we're trying to achieve, or to get into our heads, that if these two objects are coming together, this object here is our Lambo and this object here is our Corolla. They're coming together. They haven't collided as yet. The total momentum will be 77,500. The addition of this and this. Now,
Oh, what do you them together?
yes, that's a total system. So after they collide, the momentum will not change. It will still be 77,000 even after they collide. The velocity might be different, but they will be the same. Understand better now?
Yes, sir, I'm getting there.
All right then. All right, so we'll move to inelastic and elastic collision. And we said that elastic collisions occur when both objects separate after the collision. So we have a collision here, we have an object here, and an object here. They're coming together, and when they collide, they separate. They go their separate ways, right? And then for an inelastic collision, after they collide, they stick together after the collision. So they don't separate, they're together in the same direction, right? So let's say we have a stationary object here and a bigger object coming. This bigger object is coming and it collides with this object. You'll find out that both objects will stick together, just like in the depiction here. And they will be going in the direction of this particular guy here. So the velocity of both objects will be the same. The velocity would not change. So we'll have a formula looking like this, right? A formula looking like this. Because V1 will be equal to V2. And because this is so, then we can what? We can factorize. All right, let me just write it out quickly so that you can see what I'm trying to say. All right. All right, so we have M1 V1 plus M2 B2 equal M1 B1 prime plus M2 B2 prime. Now, because these two objects, this should be prime, V1 prime and V2 prime. Because these two objects stick together and they're moving at the same velocity, V1 prime, V1, let me add this person here. Where's Miss Van Horn? All right. Now, V1 prime would be equal to V2 2 prime. And because they're equal, what can we do here to simplify this? Mathematics. What can we do here to simplify this?
Cancel.
No, because V2 and V1 are the same. We could factorize, right? So it would come down to M, B, we just make it V prime, one big V prime, right? M1 plus M2 big V prime. And because these two are the same, V1, the V prime are the same, then we can factorize and we are left with V prime M1 plus M2. Simple factorization. I guess you will learn more about factorization in mathematics, all right, and you can practice more on that. But this formula, right, is very easy. You can memorize this formula very easy, right? And this comes down to be the same thing.
Sir, this is inelastic collision.
Yeah, this is for inelastic collision where both objects stick together. They stick together and they have the same velocity. Right? Anyone lost? Are we good?
Very good, sir. Very good.
All right. All right, we can move on then. So, question time. Question time. Question time. All right, so trolley A with a mass of 300 grams and velocity 9 meters per second collide with a stationary trolley B, and both trolleys move together. So after the collision, they stick together, as we said earlier. What kind of collision is this?
Inelastic.
Inelastic.
Right. So in elastic. So I'll start out with the formula, right? I'll start out with the formula and then you will guide me as to what to write. So we have M1 V1 plus M2 V2. What should we have here now?
Sir, M2.
M2, all right.
Yes. And V2
V2
prime
prime
plus
plus
the same thing again, sir.
M1, right? This was M2, so we have M1 now, right?
Yes, sir.
And V1 prime, right?
Yes.
And we said that that V2 and V1 are the same. Why? Why are they the same?
Of their velocity, sir.
Because their velocities are what? They're the same. Why?
Because then
They're
collide.
together. Yeah, they collided and they stick together, right? They
Yes, sir.
move together. So this is very important. Whenever we see move together, we know that it's inelastic collision. And then for the formula for inelastic collision, we have a big V and M1 plus M2, right? Everyone understand?
Yes, sir.
All right. All right. So actually, let's actually do the question now. So A says find the momentum of the trolley before the collision, right? So let's do that now. Let's do this down here. Find the momentum of the trolley before the collision. What is our formula for momentum again?
Mass times velocity.
Velocity times mass.
All right. So we have momentum equal mass times
Velocity.
velocity. What is our mass?
300
300
grams.
grams.
But what?
Sir,
Kilogram.
me
Sir,
grams
it's
of it.
supposed to be in kilograms.
All right, so we must convert this to kilograms. And how would you do that? We'll start with 1,000 kilogram. 1,000 grams make how much kilogram?
1.
Right, so 1 kilogram. And we have 300 right here, right?
Yes, sir.
300 grams. And we have X. We need to find the amount of kilograms. So we what we'll do next?
Cross multiply.
Perfect. Cross multiply. So we have 1,000x equal what?
300
300. 300. No, what we do next?
Put
What?
both sides, put that over 300.
Divide.
Divide both sides by what?
1,000.
Divide both sides by 1,000. Right? Let's come over here. So we now have these 2,000s cancel, right? Right? They cancel?
Yes, sir.
Cancel, cancel. So we're left with x equals 300 over 1,000. What is our final answer?
0.3.
0.3 apples.
kg, kilograms.
All right, kilograms. So we have 0.3 here. Times what?
9.
2.
Times 9. Yeah, this guy here, this is our velocity, right? So what is this answer here?
2.7
2.
kg ms. Then a negative 1 by top.
Perfect, perfect, perfect. I am so proud right now. I didn't have to do any work. All right. Before we take on the rest of this question, we're gonna pause and come back. All right. So I'm gonna close this because we have 3 minutes left on this one. I am going to close this one and then open it back. All right.
Yes, sir.
So use the same link
Okay,
and join.
sir.